about it. But you put it back and say, does it make sense? And because we're squaring it, the log of x squared, x can be negative or positive. It's okay. It's going to get squared, so I'm logging a positive at all times. So you're good. Okay, here we go. I got it. I got it. You ready? Coming at you. Eat it. Well, okay. So now there's logs. You got to isolate the log. If you want to solve this, you have to have a log by itself. You do not know what it's like. You put Nikita in a room with no windows, no doors, just padded walls. You get to know what he's like. You can find out what's inside him, what he's made of, what his X is. So that's what we're going to do. We're going to use all those log rules yesterday to condense. So I need a single log before I can solve this thing. These are all log base E. That means, hey, look at that. I got a plus sign. I got some logs. Man, we can multiply these. Okay, that left-hand side. And we can do stuff like, so this is condensing. I want to get it, solving a log equation is I got to get down to a single log, which means put stuff together. Like that square, that 2 up front there, get it up, get it inside there. So just take rules like adding and subtracting logs, put them together as a product. 2 logs made to 1. Dangling numbers out front of logs, put them up in the exponent. Do it, do it, do it. And if we're going to solve for x in this one, we're still going to figure out how do we combine these some more. Or we're going to employ another really cool thing. Check out the green blobs. If I want to know what makes the log on the left equal to the log on the right, I just got to have the same stuff in the blobs. For those 2 logs to be equal, they just have to have the same green blobs. So what you do is in these equations with logs, you get a log on the left, a log on the right, and then if you have single logs on each side, you can just set their inside green blobs equal to each other. So really, I just want to know how on earth can I make 3x minus 2 times x minus 1, which will probably FOIL out, equal to x squared, the green blob. So in log equations like this, you can have a log on each side, set the insides equal. It's a quadratic, we're going to rock this out. So 3x squared minus 3x minus 2x plus 2. That look good? Equals x squared. Subtract x squared maybe. Make it 2x squared minus 5x plus 2. All good quadratics get set equal to 0. We think about factoring it. 2. We might have a winner. 2 and 1, 2 and 1. What if we did negative 2, negative 1? We made negative 4 with these guys. And negative 1 more with those guys. We got it. Factoring? Yeah. Let's go for it. So I got 2x and 1x with these first pair. And the 2x got paired with minus 2, so you put them in opposites. Minus 1 here. 2x squared minus yeah, we got it. And that means our solutions are und half and 2. And since you guys are so good at the extraneous business, you go up there and say, are those both okay if I put them up in the original logs? Looks like 2 goes just fine, but if I put a half in to that up top here, let's make a blue blob. Right there, if a half goes in for that x up top, we got trouble. Trouble right here in River City. With a capital T that rhymes with P and it stands for, if you can name that musical, I am giving you some tamales. Man, you're good. Here's some tamales. Music Man, that's right. Trouble, trouble, trouble. Right here in River City. Name of the person that sings that song. The character?
The main guy.
The main guy? Okay.
Okay.
We know his name. How about the initials are HH? Music Man, lead character, HH. Let's isolate that exponent while we're thinking about it. Hannah's Googling. You can't do that, Hannah. That is such a party killer. We're having a great discussion. Remember that musical? What's the lead character in there? Everybody's having fun talking about it, and then the other person pulls out Google. Bam! Fun is over. You've ever been in that situation? Thanks, Hannah. Here we are. Y'all good with that? Isolate that thing. Introduce the log, and since it's so fun to bring the log in, we're going to make it pink. Does this look like the one we already did? Darn tootin'. And speaking of tootin', I've got the flarp up here if you guys are getting tired or bored. LN3, oopsie. And we're going to multiply by 3. I just wanted to give you one more shot at this. One more time. Now we're going to play. You guys are ready to tackle this stuff. Okay, so we're going to take that whole thing times 3. Log of 2 over 32, log of 1/4 times 3, get the decimal, and go home. We'll talk about those decimals here later, but in the meantime, let's close this out and call it a day. Tomorrow we do Newton's law of cooling. It is cool. We'll actually bring in some water, and I'll show you guys how that works. We'll cool some water. I got you on that one. Cinco. Let's make some quick work. I just need to give you some experience before you tackle your own. I want to isolate the exponent, so you divide by 3 first. I know that sounds weird, but I want to get to the exponent by itself. And then therein is your opportunity to log it. 96 over 3, which will simplify. I'm going to log both sides. Pull the exponent out. That is 32, at least for my calculations. And then if you are very savvy, there's a pattern. We got ln 32, got divided by log of 4, and then we ended up multiplying both sides by 2. So I'm trying to get, that's 3 exponential solving problems. They all kind of went the same way. Divide by the number out front, log both sides, divide by the log, multiply by the denominator. So, and then it's all calculated from there. Cease. Look at it. There it is again. Divide by 3, divide by 3. You're getting good at this. I want you to stop and pause for just a second on this one, though. Because look what I just did. You're welcome to take the log of both sides. You are. It's cool. You can finish just the way we did the last one. You'll be awesome. But I want you to notice something this time. Excuse me. This and this. Those have the same base. Again, taking the log and continuing out is just great. But if I have the same base at some point along the way, I can just set the exponents equal because 5 to the something is only going to be equal to 5 to the something if their somethings are equal. The blue blob's got to match. So really, I can just go, hey, when is negative x to the 4th going to be 1? Or negative x over 4, sorry. When's it going to have that? And I can solve it from here. X is negative 1/4. Or you can do logs of both sides and do that way. Up to you. That's a little insider trick. Moving right along. Moving right along. We can do these two, knock them out. 2 to the 5th equals x. We're done. It's a log. To solve logs, you convert them to exponents. And actually, this is exact, but you can write 32 if you like. 4 to the 1st equals 1 minus x. Once you have a log by itself, these rock. And I can add x, subtract 1, so x is 3. Negative 3. Done.